Welcome back, my friends, to another lovely math video. We're reviewing for the final, and I hope you're having a good time learning all this math. Oh, the joy. Well, whenever I see a quadratic, my gut instinct here is to factor. And so they're asking for the excluded values, meaning the numbers that are not allowed. And what's not allowed is to have something that gives you 0 in the denominator. The number 0 itself would actually be okay, because if you plug in 0 here, you would get 2 over 2, which is 1, and that's perfectly fine. But there are possibly some numbers that would be a problem. And so if you factor this here, it has to multiply to 2. They're both positive, so it has to be k plus and k plus. And it has to be 2 and 1, because that's how you get 2, because it's a prime number. So this is what we have. And that means the excluded values are -1 and -2. Those are the excluded values. The numbers that are not allowed. The numbers that are not in the domain. Here, it's simply 0. Because if n is 0, then the denominator becomes 0, and that's a problem. Number 15. Simplify each expression. As always, please pause the video and try it yourself. And we'll be right back with the explanation, and we're back. Ready? All right, here we go. So factor the numerator. All right, so let's factor this. Yeah. So we are going to set up our parentheses. And 5 has to be 1 and 5. And because it's minus 6k, it has to be minus minus. I don't know why I didn't put the k in first. It's just... All right. And then I'm also going out of order. It's got a little distracted. So this is going to be k minus 5 and k plus 3. And then let's not forget, we also have the 7 and the k minus 1. Again, I apologize for going out of order a bit. I guess the lesson here is that the good news about multiplication is you can change the order. So this is going to cancel with this, and this is going to cancel with this. And so the final answer is 7 over k plus 3. And that's it. Number 16. Here's an interesting one. This happens a lot. What do you do in this? It seems like they're the same, but they're not the same. And the order is different. But in another sense, they are actually very similar. Whenever you have this, a minus b over b minus a, it's -1. Because 1 minus a, if you multiply both by -1, you get -1 plus a, don't you? Which is a minus 1. So the only difference there is, of course, that -1. So that's why that's -1. Okay, so that's -1. And then this part over here is a plus 7. And on top, we have a plus 7 times a plus 3. And so I get that, and a plus 7. Those are going to cancel. Man, that's an ugly 7. I apologize for my handwriting. At least I got to cross it off. Did I even write it as 7? Like, come on. Whatever. It doesn't matter. It's gone. So the answer is -1 times a plus 3, which is minus a minus 3. Minus a minus 3. And that's our answer for number 16. Number 17. We're just going to keep going. In fact, let me zoom in a little bit better. For people watching at home on the video, it might be better to just do this. Again, pause the video and wait for the explanation, and we're back. 9 times a squared. No, actually could take out 9a. And that will give me, yeah, I'll rewrite that. It's a little ugly. And that will give me a plus 3. A, come on, a little bit nicer. A plus 3. And that's over this one here. Again, just use your Xbox. And so Xbox says that 3 times 10 is 30. So it has to be a plus 3 and a plus 10. And then this over here, I'll go ahead and just add it to the numerator, because why not? And that's, so I'll just put that right here, a plus 10. And then we also have over 21a cubed, so 21a cubed. Let's see what we can cancel. This is the same as this. Oh, I didn't finish that. And this is the same as this. If I divide both by a, this will be a squared. If I divide both by 3, this is going to be 3 over 7. So the answer is 3 over 7a squared. How about that? Again, please pause and review, and we'll move on. Here we go, dividing by a fraction. Remember KFC, keep, change, flip. In order to divide by a fraction, you have to keep the original. And so I'm going to rewrite the original fraction, the one on the left. With one difference is that I'm going to factor out the 9p that I can factor out. And so that gives me p minus 8. Minus, unfortunately, not plus. That would have been nice if it was plus. Would have had a nice factor, but we don't. And sometimes that happens. And then, so division. So keep the first fraction, change division to multiplication, and flip the one on the right. And now I'm actually regretting. Oh, wait, no, I'm not. I'm not regretting anything. This cancels with this. And so the answer is p plus 8 over p minus 8. And the times 1 just doesn't matter. And that's it for number 18. All right, here we go. Number 19, you're supposed to add the fractions. Please pause the video and try it yourself. And we're back. And so we're going to multiply by 3r plus 1 over 3r plus 1. And so I'll just put that like that. Oh, and on the left, we're going to have to multiply by 6 over 6. Because if these are going to have the same denominator, they have to have the same denominator. So that gives us 24r over 18r plus 6 plus 15r plus 5 over the same denominator as on the left, which is 18r plus 6. Whoop, seems like my audio cut out. So I just added the numerators together, and we have it over the denominator, same as before. And that's it. We're done. We did it. Is there anything to factor out? No, there's not. There's no common factors. We have finished adding the two fractions, and we are happy. Very, very happy. Number 20. Again, please pause the video and try it yourself, and then come back for the explanation, which is right now. So here, interesting. So I don't have to multiply by 4n minus 8, believe it or not, on the left. Because actually, on the right, if I want to rewrite this, let me rewrite this for you. So on the left, it's still 3n over 2. But you see how the denominator is just a 2? Well, I could actually factor out a 2 from this one over here, and that would make it 2n minus 4. And then I would have this 2n here, right? So now all I have to multiply by is the left one. I'm kind of out of space here. Let me see if I can. No, I can't. 3n plus 2. Let me see if I can make this better. 3n over 2. How about that? And now I'm going to multiply this by 2n minus 4 over 2n minus 4 so that we have the same denominator. And we do. The numerator is going to give me 3n times 2n is 6n squared. 6n squared minus 12n. And the denominator is, well, it's what we had before, 4n minus 8. And then this is plus 2n. And I'm just going to go ahead and just add the numerators and keep the denominator the same. So this is going to be 6n squared minus 10n all over 4n minus 8. And actually, maybe I should have left it as 2 times 2n minus 4 because I can factor everything. I can factor it to 2, so I can divide everything by 2. So let me just divide everything by 2. Same difference. And that's going to give me 3n squared. And yes, I'll leave the n alone. It's fine. Because there's no n that factors out in the denominator. And that is all over 2n minus 4. And that, whoop, if I can get this to right, is that. And that is the answer for number 20. See here, number 21. Number 21. Well, geez, this one here is just v. So I don't know why I would have to bother with that 3, and I don't, so I won't. So I really just have to make the denominator on the right look like the one on the left. And so I guess I have to multiply by 2v by the whole denominator over v plus 2. All right. Here we go with this. So we have this right here. And now they have the same denominator. So now we have that. So we have that. Okay, it looks good. Just double checking everything. Same denominator. Yep. Everything's good. So I'm going to have to actually do this out and then distribute this. So before I do that, I just want to acknowledge that v times 2v is just 2v squared. So here's what we have. We have the original function, fraction, over, I'm just going to go ahead and write this, 2v squared plus 4v minus, so this is going to be 2v squared times v plus 2, so that's going to be 2v cubed plus 4v squared. Now, I think that might not be clear, but what I'm saying is this v right here goes here, and it's going to make that 2v squared, and so I can just get rid of that. And so if I multiply 2v squared times v plus 2, I get 2v cubed plus 4v squared. And that is over the same denominator as the other one, plus 4v. And now I'm ready to subtract the fractions. And there's actually no overlap. So what we're going to get is we're going to get this minus here. If you think of this as being a parentheses, this minus gets distributed to both of these. And so we're going to end up with minus 2v cubed minus okay, so they both get a minus. And it's still over that same denominator. Whoop. Nope. Sorry, I forgot the other parts. Plus 2v plus 3. Plus 2v, because we're supposed to have the numerators together. Plus 3. Okay, that seems good, and that's over the denominator of 2v squared plus 4v. And I can't factor anything out that's going to factor out of the numerator, so I'm done. And that's all there is. And the last question is determine the degree. Well, this right here is the highest combined degree. Therefore, this is 11. So that's really confusing because we've never seen anything like this. Like, that's a weird expansion, right? Here there's 9 and 1. Here there's 6 and 3. For like, what kind of expansion is that? Well, I mean, it's not a typical expansion. We're supposed to like basically like use our imagination, I suppose. But the way the highest degree that it could be here is 11 because of the 4 and the 7. So there we go. And then over here, I'm just looking for the biggest sum. 5 and 8 is 13. 11, 8, 11, 1. It's 13. And that concludes our video. Hopefully that was helpful to you. Please like, share, and subscribe. Buy my merch.